Go.
All right, here we go. Chapter 2. Now, here's the issue.
Chapter 3.
It's chapter 3. Oh, we're off to a great start. Whatever, it's science. Who cares? Here we go. Chapter 3. See, I know my stuff. Okay. Now, you notice why I'm wearing a hat. Let's kind of preview for chapter 4, insulators. Okay? It's getting kind of cold out there, so I'll just keep this on for the heck of it because I don't really care. Okay, so I'm going to talk about, along with Miss Boyer right here. Miss Boyer, say hello to the camera.
Hello, hi everybody.
There you
How
go.
are you?
There you go. Now we're going to hold off on speaking German until next month because it's kind of hard for us to do that, so we got to practice a little bit. So Germany, we know you're there. We know you're watching. We're sorry. I promise on chapter 4 we'll have some discussion in the German language. All right, but Germany, you guys win. Where's India? Where's Mexico? Where's Great Britain? Canada? Hello, are you there? Watch us. Let's go worldwide.
Poland.
Poland. Where you at, Poland? There you go. Right. Okay. GPE, potential energy, is stored. Kinetic energy is energy in motion. Okay. So I'm going to talk about, we're going to keep this basic so everybody understands it. So we're going to talk about GPE, stored energy given gravity and height. So here I am standing on the floor. I have no defined height. Our zero height is the floor.
His weight is the same.
My weight is the same.
Weight's the same.
You got it, because GPE is W times H. And I'll draw that on the board in a little bit. But now I'm going to move up. Now when I talk about my height, it's from the bottom of my foot. I'm standing on a chair.
I'm going to come on over here.
Yeah, that's cool. Come on over here. I'm standing on a chair. So my height is from the bottom of my foot to the floor.
All right, we got it now. We got it.
All right. So now I have some GPE, which eventually will turn into KE. But we'll get to the KE in a minute.
All right, I'm going to zoom out. Can you do that again so we can?
Yes.
I'm practicing on the zooming out.
Miss Kardik again. So Mrs. Kardik, if you're watching, Miss Camilleri likes it when I annoy you when I jump on the floor. Okay, let that be on the record. Okay, so again, the GPE depends on weight. Not like, wait a minute, like weight, gravitational force, and the height. So now I'm at maximum GPE, right? As I go down, that GPE, I start to move, will turn into kinetic energy. So watch. Max GPE converts to kinetic. That's not much though. Let's add some more GPE. Shall we store some more GPE? Store some more. All right, let's store more. How should I store more? Should I start here and go down? Or should I start here and go up?
I think you should stay up.
So I should go up again?
Yeah.
So I add like here?
Yeah.
Oh!
Yeah.
Okay. So,
Be careful.
oh geez, okay.
Be careful, Mr.
Here we
Parsia.
go. You wanted me to know in this card, Miss Camilleri. You wanted me to. Okay, now look here. I've now increased my height, but my weight is the same.
Yep.
So now we have more stored energy, more GPE. Okay? What could that mean? What will it mean when I jump? There will be more kinetic energy. So the greater the amount of GPE you start with, you've got more to convert to kinetic. Okay?
And he's going to make a big crash too.
You call me fat?
No, your mass. Your mass.
That's right.
Mass.
That's
It all
right.
depends on your mass.
Here we go.
Weight.
You know it. Here we go. And now I'm going to jump. Max GP converting to KE. So as I fall, higher height, more potential energy, more to convert to kinetic. And we're going to put numbers in here in a couple minutes, okay? Am I doing okay so far?
Doing great.
Awesome. Shall I store some more?
Store some
Let's store more!
Woo!
Cheer. Store some more.
more. Store some more. Store some more.
Let's store some more. Here we go. Oh boy. All right, now move this desk over.
All right.
Now I'm going to go up here. Okay.
Be careful, Mr. Parsia. Be careful.
There's workman's comp out there or something. I don't know. So,
Okay.
All right. No, wait. Are you going to jump forward here?
oh, I will. Yeah, come right
Okay.
here.
Let me come around here.
Don't give it away. Don't give it away. Okay,
Oh,
good.
whoops.
So now I've increased my height even more. Store some more.
But the weight is the same.
I'm still the same person. I'm still the same weight. Okay, now watch this. So now I've got more GP, which means now I want to ask you this. What do you predict the kinetic energy will be? Do you think the kinetic energy is now increased given what would happen? So if I've got more stored energy, will there eventually be more kinetic energy? Think about that. The answer is, give me a second to think. Yes, it would be, okay? And we'll put numbers in a minute. Yeah, not yet. Hold on. So now let me throw in a friend here. My awesome eraser. What's the difference between me and the eraser?
You're heavy.
What?
You're heavier. You weigh
Heavier.
more.
Thank you.
You weigh more.
It's okay,
And
okay.
the eraser weighs less.
Bingo. So let's say here, so is the eraser and me at the same height?
Yes.
So do we have the same GPE? No. But we're at the same height. Wait a minute. I obviously weigh a lot more than the eraser. So I have more GPE than the eraser. So who will eventually have more KE if we both fall? Me, because I have more stored. Okay? Do you think this is kind of clear? Do you think I'm doing good? Am I doing
I think
good?
you're doing
We're
great.
doing good, and I will put numbers in a minute. Okay, give me the chair. Let's
Yep.
go crazy. Let's go crazy. Here we go.
Woo!
Store some more?
You're gonna store more?
I'm gonna store
Oh
more.
my! Oh, I'm so nervous. Oh, I'm so nervous,
All right,
Mr.
now you gotta move
Parcia.
that
Be
chair.
careful.
All right, move this chair. All right.
Oh dear.
All right, here we go. I'm going to store. Oh,
Oh,
You're gonna
no.
go through the ceiling tile.
no. Here we go. Ready?
Oh, my
Store some
goodness.
more.
You want me
So,
to hold that?
no, that's cool.
No? You're good.
So now we're going from the floor to
Right
the
here?
chair to the little desk to a bigger desk to a chair. So the height is increased, but the weight is the
Same.
okay. So the GP is increasing, which eventually will mean that if we fall, the KE will eventually be larger. All right, now I'm going to stay. Here we go.
Oh dear.
Oh boy!
Oh, no.
My
Ta-da!
GPE is even more!
All the way from the floor, all the way up.
My
Woo!
GPE is even more! All the way from the floor! Alright, this is awful. Alright, here we go. Who cares? It's good. Okay. So now, I've got more GPE because I've increased my height even more, even though my weight is the same.
Same.
Okay. Now, let me ask you something. Back to my little eraser friend here.
Yeah.
Alright. Let's say this lit eraser. It's at the same height as me. Say we both jump, and I'm not jumping off this chair. Okay, I'm not that crazy. I'm crazy, but not that crazy. Which one has more potential energy? Or do we have the same? Me or the eraser?
I think you.
You think me?
Yeah.
Because I have more what?
You have more stored energy.
Because I weigh more. You got it. Perfect. I weigh more, so I've got more potential energy than the eraser, even though we're at the same height. So, now what if I did this?
What if you were to jump from
No,
there
I ain't jumping from here, but I'll do, oh geez.
and
There you go.
Oh, hold on a second.
Oh.
Hold on a second. Yeah, I'm getting dizzy up here, but I'll be okay. The
Don't
eraser,
fall.
this is like, you know what? People are going to be sitting by the computer. Will he fall?
mesmerized.
Is he gonna
Like
fall?
seriously,
They're gonna
will
be
he fall?
mesmerized.
Oh no!
Where's
Will
the
he fall?
first aid kit? I don't know.
We got Miss Bradfield down there. Hold on. But think about it. All of Springford area is on pins and needles right now. Will this crazy teacher fall? Really, I hope I don't. Okay.
Even the camera
so
person.
Who has more GPE now? Now wait a second. Let me go through this. This is light, but it's at a higher height. I'm heavy. I'm at a lower height. Okay. So if GPE depends on weight and height, who do you think would have more GPE? It would probably be still me. Because I weigh so much more, right? The difference in weight is so much more than the difference in height. Is that clear?
Does that mean you would fall? Like if you were to jump
There'd
up
be
there,
more
you would
kinetic
be
energy.
faster than that
Well-
eraser.
Well, then there'd be more kinetic energy.
You'd be like speed lightning.
Yeah, oh yeah. So anyway, the thing is with this, I have more GPE, even though I'm a little bit lower. It's not because of the height this time, it's because of the difference in the weight, okay? Just because you're higher doesn't automatically mean you have more GP. You have to take the weight into account too. Okay, now, let me put some numbers in on this.
Careful.
Whew, okay.
Do you want this on video here?
Oh, yeah, I don't care.
Getting.
I'm going to jump. Here, I'll jump from here.
All right.
Okay, here we go.
Oh,
Now I'm
dear.
going to convert GP to K as I fall to the floor. Here we go. Yay! Oh!
Ah.
Okay, now, I left the eraser up there. Oh, well. Okay, let's go to the board real quick. I'll summarize this on there. I'll hit EP real quick. We'll go from there. Okay, here we go. So here I am, look here. Here is the chair. Here's the floor. Here's me on the chair. Here is now me, we'll call this A. Here's this small desk, B, so I'll make it a little bit bigger. B. Here is me on the taller desk, we'll call that C. Here's me on the desk, but on the chair. D. Okay? So if GPE depends on weight and height, the weight is the same, my weight is the same. I'm going to put a horizontal arrow there. I'm going to put a horizontal arrow, mean the weight is the same. What's different? As I go from A to D, the height gets bigger. As I go again, small height, biggest height, okay? So now here I've got the most stored energy, right here. This is the greatest GPE. So I'm going to make up a number, just so you kind of understand it. I'll give this value, we'll go, give me a number, like 100?
100.
100. We'll say my GPE is 100 joules. And again, I'm making up that number. At the bottom, or right before I hit the bottom, how much KE could I have up to right before I hit the bottom? 100 joules, because it gets transferred. I start off with the maximum GPE up top, it converts to kinetic energy. What's my GPE value going to be? About what? Zero. Where'd it go? It turned into kinetic. Okay? Your teachers will go through thermal energy with friction with you and how some of that gets transferred out. This isn't an ideal basic situation. Okay? The GPE converts to kinetic energy. And kinetic energy is motion. Well, if it's motion, as I'm falling, I'm speeding up. So kinetic energy comes up. Okay? Here, let's make up the number. Let's say I'm at 80 joules right here for GPE. Why 80? Because the height is less. The weight is the same. How much kinetic energy could I have up to? 80 joules with a GPE of about 0 at the bottom. So this becomes this. Down here I've got, we'll say 50 joules of GPE. 50 joules of GPE. Why is it less? Because I'm at a smaller height. The height is now dropping. How much KE could I have up to? About 50, even though my weight is the same. And last but not least, let's make this number 10 joules of GPE. How much KE could I have? I could have up to 10 joules. Okay? So the greater the weight, the greater the height, the more GPE, the more kinetic energy you could have. All right? Your teachers in class will go through 50-50, and we'll talk about friction and things like that in class. But the key concept, right, Ms. Boyd, that key concept, right? We love key concepts. Whatever you store, you have that ability to convert it to motion. Okay? And GP depends on weight and height. Well, the other form is this. EPE.
Oh, be careful.
No, yeah, I know. EP, I'm not a good rubber band flicker, but let's predict. Elasticity. Same concept. But EP is the greater the stretch. What do you think will happen if I stretch this back really far? Will it travel a little bit, or will it travel really far?
Even more, even more.
Then it'll travel and go even more. So if I stretch this rubber band a little bit, little EPE, then all I will get is a little bit of KE. If I pull the rubber band back even more,
It's going to go farther.
It's going to go farther, so there's going to be more motion. So more KE. Farther, more EPE, more KE. More EPE, more KE, and so on. Very simple concept. Okay? So usually, pretty much whatever you store is what you could get out of it in motion. And that's the basic relationship between potential and kinetic energy. The other form of potential energy, I want to talk about for like 1 second, is stored chemical potential energy. Okay, and that's found in the food we eat. Okay, we can burn it, we can find it in wood, we can find it in many different things. Chemical energy is stored energy in cells of objects with living things. Okay, that's a really big example. Okay, and they help us function. A lot of times when we run, I'll give this free saying away. I had some kids run in the hallway, And running, it's taking chemical energy, transferring it to mechanical energy. But they feel this air against them. They feel the heat, thermal. So when a person runs, it's chemical and mechanical, but they also feel the heat. So we ran. We ran around the hallway, chanting to ourselves, chemical, mechanical, feel the heat. Woo! Chemical,
I have to
mechanical,
keep up with it.
feel the heat. Chemical, mechanical, feel the heat. Chemical, mechanical, feel the heat. Chemical, mechanical, feel the heat.
I can't keep up with
feel the
you.
heat. Now, real quick, shut up. I will shut up. I know I love to talk.
I totally zoomed.
I'm really feeling the heat because in chapter 4 we're going to talk about how heat transfers out or in objects. Given this hat, heat wants to rise out of my body, but this is insulating it and slowing it down.
Oh.
That's next chapter.
Next chapter.
Next chapter. Sorry,
Preview.
Did I do okay?
That was great.
Am I good?
Great.
That's
Let's
good.
switch.
All right.
You ready? Okay, here we go.
Really good.
All right, here we go. It's
Where am I
still going.
That's
Is that
good.
okay?
We like it live. Live is a good thing. Where am I going? Okay.
In here.
Where? Your room? Feel the heat. Woo! Chemical, mechanical, feel the heat. Chemical, mechanical, feel the heat. Chemical, mechanical, feel the heat. Whoa, man. Where am I going?
Turn on. We're talking
Turn
about
on your heart light.
energy.
Let it shine
burning.
wherever you go. Neil Diamond, go ahead.
We're going to turn this on.
Oh, yeah, duh.
Here we go.
I'm thinking
We
about
don't
Neil
have enough
Diamond.
Electromagnetic energy here.
Whoa, can
Oh.
you know what? I'm the world's worst camera person. Can you do that again? Because, of course, I film a ceiling tile, not a light. Let me start.
Let me turn
Okay, you're going
both-
to turn on
let me
the...
turn both.
Whoa! You turn...
Alright.
Okay, turn on the switch.
So turn on the switch.
Whoa.
Electricity can flow through to our lights, and then we have electromagnetic energy.
Visible light. Woo! There we go. Awesome. So electrical to electromagnetic at the... Where's the thingy? Light switch.
The light switch.
Nice. Okay, cool.
So,
Nice.
Mr. Garcia talked about how kinetic energy can change to potential energy to kinetic energy. But we can look at more specific types of energy as well and how they convert from one form to another. So that was electrical energy going to electromagnetic energy. And in class, your teachers will talk about that extra thermal energy
Feel the heat.
that light bulbs may produce, and we don't want that. That's that wasted energy.
Quick question. You want me to focus on you here? I'm on you. Okay, good. I'm on you. Go ahead.
Are we good?
Yeah, we're good.
All right, so other
What's
energy
that?
conversions. This is a wind-up, like, flashlight.
A wind-up flashlight. Yo, wait a minute. Should I stop the electromagnetic energy from the light bulbs in here and cut off the electricity, or do you want me to leave
All
the
right, well,
big
go
lights on?
ahead. Here, I'll do this part so you can see it.
Oh, wait, hold on. Wait a minute. What are we doing here?
That's pretty good. We'll give a little shout out to Eddie Bauer here.
They're at the outlets. Good prices on things. This
We've got all-
program's sponsored by Eddie Bauer. Here we go.
Maybe we'll get some coupons.
Yeah,
All right.
if it's free, it's for me. Go ahead.
Flashlights, you can have batteries inside.
Ooh, stored chemical energy.
That's chemical energy that would transfer to electromagnetic.
Mm-hmm.
But we're finding out there's energy transfers forms. You cannot create energy. You cannot destroy energy. It just changes forms. That's
So-
the law of conservation of energy.
So you always got to account for it.
Right.
Yeah, cool.
So, but that means we can find different ways to transfer energy from one form to another. So here's one. What you do, there's a little bit of sound energy
Ooh, yeah.
there too. But you crank this up,
You got to be kidding me.
and then the light,
Whoa!
you get electromagnetic energy.
Look at that. I wonder if that's efficient, those light bulbs in there. I'll bet they are.
I think that's an LED light.
Ooh, ones that don't get, you really don't feel the heat, I guess, too much, right?
Right.
Ah, that's what makes them
So
efficient.
it's more energy efficient.
So just with the turn of that crank, you get light like that.
Right.
Wow, look at the technology nowadays. That's awesome.
So the more energy efficient too. A lot of kids think that it means you're saving energy. It just means that you're getting more of the energy to what you want it to do.
Oh, yeah.
Less of that thermal energy with those LEDs.
So you're getting what you need by consuming less. Is that pretty
Right.
much a good way to say it, I guess? Yeah.
You got it.
That's a
You're
good
not-
way to say it.
You're not using electricity to get to something that you don't want.
Oh, man. You're going to annoy Pico. You know that, right?
I know.
Pico's not going to be happy with you.
Right.
You're not using up their electricity and giving them
I
money.
have an insulator in here too.
You have an insulator?
Yeah. My coffee cup.
Uh-oh.
That's a good insulator.
That is a good insulator.
Keeps my
Oh, we're
the
gonna.
thermal energy of my
That's gonna
coffee in there.
That chapter's going to be insane. I can't wait to get to that
That's
chapter.
gonna be great.
That'll be good. So we ran. We did light bulbs. What about an overhead? Do you want to talk about my? You want to go back tomorrow and talk about my overhead? Let's talk about how. Well, I love an overhead, but I'm not doing our world much good by using it. Do you think?
Oh, no.
Well, I'm doing our kids good because that's how I teach off it. But like, I'm not really conserving too much energy and stuff. So we pull that old school thing, or just pull that sucker up here.
You can do it. Do you want to do it?
Oh, no, I'll talk, just plug it here.
You want me to plug it in
Oh, yeah.
back here?
No. Just bring it up to the front. Oh, turn off the electromagnetic energy. Pull up to the front. Pull up to the front. And I'm going to ask you some questions about what you see and hear on that thing.
All right. Motion. Oh, it's over.
Here. No, here, I'll use them. Oh, wait a second. So now I'm going to plug it in. Oh, wait, that's calculations. I shouldn't use it. So now it's going to go into the outlet. Now, wait a second. You notice this cord
Can you
is
see?
made of, it's made of like rubber, so I don't get electrocuted because the electricity can't travel through the rubber. But you notice this metal right here. There's electricity in that wall. So how's that electrical energy going to power that beautiful overhead? Do you know how to pull that thing up? Here. See that little blue thing right there? Up.
This?
Yeah, pull that. Somehow.
I don't know. Or this.
Here, I'll help you. This camera, this is why you have a smart board, just so... Oh, wait a minute. I don't even know how to do it. Hold on. Here,
Oh, there
we got
goes.
it.
There it goes.
There it goes. Cool.
Oh,
Here we go.
there you go.
So now, this is awesome. Okay, now watch. Oh!
Oh.
Turn it on.
All right.
Turn
you
on.
ready?
Turn on. Here we go. Turn on. No!
Nothing.
What do I need? What do I need? Electricity to get light. Okay, now keep it on. Just keep oh, now watch this. I'm going to plug it in and tell me what happens.
This is against all rules.
Oh, yeah, you know what? Turn it off because somebody will call and complain that I'm doing that. Go ahead. Yeah. I know. And plug it in. That's right. Oh, electricity's traveling through. Now, we're actually running out of battery on this camera, so we got to get moving. So turn it on. Ow! Light. But wait, do you hear something?
Yeah.
Not only are we using electricity to give off light, which is what we want, so we see the image, there's like a fish. Hear that sound energy? Does that sound energy really help you learn directly? Do you think that helps the kids, that sound?
No.
There's a fan in there. So there's mechanical energy movement, there's sound with the fan, and light. And there's heat being given off.
Yeah.
Ugh,
Your
yuck.
kids, when I had an overhead, my kids never liked to sit next to it. It
Yeah.
got so hot.
I know. All that just to give off light, to project an image. Okay? So an overhead converts electrical energy to primarily light. But also to do that, it's got to give off heat, it's got to run a fan, it's got to give off sound. It's not efficient. And we always tell the kids, I go, hey, Mom, can you turn on the toaster? I can't see in the kitchen.
Right.
Well, because
You
kids
don't
think,
do that.
because kids think, like, you turn on the toaster, you get electromagnetic energy.
Right.
Well,
But that's not the purpose of it.
Please dial 2521.
Coach Greco, but that's not the purpose of
That's
it.
not the purpose of it.
So when you do an energy conversion, you want to ask yourself first, you know how you go, what to what, you know? Don't you think you want to kind of like ask yourself, what do you want it to do and fill the second one in first?
Yes.
So like, what do I want a toaster to do? Light the room? So, I'm going to put electromagnetic energy. No, you want hot toast.
Right.
So it's going to give off thermal energy.
Thermal energy.
And then you ask yourself, where are you going to get it from?
Right. You have to
Electrical.
Plug it in.
Plug it in, plug it in, electrical to
A lot
thermal.
of kids want to say, oh, but you have to push the down and it makes sound. And yeah, those are all other forms of
Yeah.
energy. But the reason we have the toaster, thermal
Electrical to thermal, straight up. All right, I think we hit it pretty good
we're
today.
good.
That was good.
energy. All right.
All right, well, thank you very much. This is chapter, what
Three.
chapter is this?
Chapter
3.
three.
Chapter 3, you can tell I'm
Very
with it.
good.
All right, here we go. Have a wonderful day.
Study hard.
Study hard. Have study parties. Have fun, work hard. All right, thank you. Hold on, let me say goodbye. Whoa, bye.